right. My glasses. Okay, well, let's get started. Good afternoon, everybody. All right, so now we've got some lunch in our bellies. So now the challenge is, how do I keep you awake? And you know what? That's okay. I won't get offended if you nod off. That's all right. But I'm going to try to make this interesting as much as possible, as much as interesting as tank installation and inspection can be. And by the way, when I say tank, we're not talking Abrams or M1 or anything like that. We're talking septic tanks. Thank you, Frank. All right. So, tank inspection best practices. So once again, for those of you that weren't in the earlier session, my name is Claude Gauguin. I'm with the National Precast Concrete Association. We are a trade association that represents makers of precast concrete all over North America. And we have about 1,100 members throughout North America who make precast or supply to the industry. So we are here flying the flag for them and doing some education as well. So really appreciate the invitation or the opportunity to speak here at TOWA. So what I wanted to talk about today during this session is just a few things about, and this is precast tank specific, so you know, that's my expertise. So I'm not going to really be talking about fiberglass or anything like that, but just precast tank installations and installation and inspection best practices. Because when we're putting in a system like this and we're doing inspections or installations and then inspections, we're trying to avoid issues, right? We're trying to avoid issues like this, you know, trying to make sure that because you don't want it to get to that point. Or things like this. You know, on the drawings, it looked like that because it was two-dimensional. But I didn't know that the stairs had to be offset. So, you know, that was a little hard to navigate. And then, you know, I like this one because I'm not up on my ADA requirements, but I'm guessing that this handicap ramp is a little out of code. So, you know, somebody obviously wasn't inspecting. Somebody wasn't doing a real good job at making sure that things were done right. So we don't want to do that with these systems. So what do we expect from a precast concrete tank? So I'm just going to throw that out to the audience. You shout it out. What, you know, for some of you inspect it, some of you maintain them, some of you install them, some of you make them. What do you want out of that? What do you want out of us? What do you want? What are the things you're expecting out of a precast concrete tank? Number one, watertight. All right, that's always one of the first ones, right? Watertight. Okay. What else? What? Durable. Very good. Got to be durable. Watertight and durable. What else? You don't want to see any steel sticking out. That's right. That's right. No steel sticking out. The only steel that should be sticking out of a tank would be the steel that's being used to lift it. And then, you know, that's specifically for lifting it. Otherwise, not the reinforcing, right? What else? Watertight, durable, no steel sticking out. We want to build the code, maybe, built right, built the code. What is it? The PSI? Okay. So when you say PSI, you're talking about the strength. Okay. So it's got to be strong, right, to be able to withstand the, uh-oh, here comes the paparazzi. Hold on. Got to get my beach body on here. All right. Okay. So, yeah, we want it to be watertight. We want it to be strong. So look at that. I had that all predicted. Watertight, strong, durable, made to specifications, and, of course, functions effectively, right? It functions effectively. So there's certain things about the design pardon me, of a septic tank that lends itself to how effective it is at doing its job. Whether it's housing just a tank for settlement or clearing tank, or it's housing an aerobic treatment unit or some other kind of secondary treatment. So the TCEQ, going back to the rules, I always like to remind everybody of the rules. 285.32 says the septic tank shall be sturdy, watertight construction. All right. I'm with him so far. Tank shall be designed and constructed so that all joints, seams, component parts, fittings prevent groundwater from entering the tank and prevent wastewater from exiting the tank except through design inlet and outlet openings. I like that language. The person that wrote that in here? No, all right. But I like it. I like it. It really explains it. You know, not just saying watertight. We don't want to keep what's out. We want to keep what's in. All right? And that includes the joints, the seams, etc. Then it goes on to say, shall be structurally designed to resist buckling from, and then here again, it goes outside and inside. It doesn't just say loads. It says, I want it to hold up against loads from the inside, right? Internal hydraulic loading, and loads from the outside, from dirt, from additional surface load. So, tanks exhibiting deflections, leaks, or structural defects shall not be used. Okay. So there are the rules. They're set up. So when we talk about forces, and we talk about what we got to withstand, let's start with that. Let's take a look at that. Let's get into some physics. All right? What kind of loads are we looking at? Well, generally, when we're talking engineering, there's your live loads, and then there's your dead loads. And your live loads are going to be traffic, your water table, the contents of the tank, loads that are not permanent, right? But dead loads are the load of the structure itself, the soil loads, things that are there pretty permanently. So when we look at an underground tank, let's just dissect this load by load. First of all, there's the weight of the tank itself, the weight of the tank pushing down on the soil. And in order for us not to be in perpetual chaos, there would have to be a load pushing back up on the tank. Otherwise, the tank would just keep going underground, right? So when I'm standing up here and I'm pushing down on this floor with, I don't know, about 190 pounds, the floor is pushing, what? Oh, easy now. Easy now. All right, when I put my other foot on the scale, you got an equal and opposite force pushing back up on my feet, right? So we got an equal and opposite load pushing back up on the tank. So the weight of the tank pushes down, weight of the soil pushes back up. Now, the ideal situation is for the soil to push up with a distributed load. The weight's going to be distributed too. It's not just going to be a point load like that. But the weight's going to be distributed of the tank, but then we want the soil to push back distributed too, right? So that's where the installation best practices come into play. Because if we have a big rock under there, we have something, suddenly we're taking the entire weight of the tank and everything above it, and we're converting it to a point load underneath, right? So we want to try to avoid the point loads. And depending on the material, that can be more critical sometimes than others, having that one point load pushing in from below or from the side. So that's why we want to try to have something pretty even, avoiding the humps in the middle, on the backfill, or on the bottom, I should say, subbase. All right, well then, so that's bottom top, and then we got some loads from the soil pushing in, right, pushing into the tank. So it wants to collapse that tank. And that's, then you got loads from the soil on top, wanting to push down on that lid. We were just talking earlier about the lid and where the reinforcement should be. So it's gonna want to try to curve that lid inwards. Then you've got traffic. Now your tank may not always be traffic rated, but you may get some sort of traffic. Lawnmower traffic, parking your boat traffic, some kind of traffic back there, but that's where the load would be applied. Now, the load from traffic has to be considered, obviously, if the traffic's on the lid, but sometimes if that traffic is close, we have to consider it as well, because we may have a load, surcharge load coming from the side due to that traffic. So if this guy's parking a semi or a pretty big vehicle right next to a septic tank, it may be pushing the soil right up against the side wall. So that has to be, that could have an effect. Then you got water. You guys got high water tables here once in a while? I'm guessing so, yeah. So water tables, now you got that coming in. So now you got water coming up around the tank perhaps, and that brings the loads from the water wanting to collapse the tank along with the soil. And then what other loads do we have due to water? Buoyancy, right? You guys, has anybody ever seen a tank pop out of the ground like a submarine? Yeah, okay. So you got buoyancy loads, right? When you got high water table, you got buoyancy loads. So the additional loads you see down here. Now, we haven't even talked about the inside of the tank yet. This is a tank that is completely empty but backfilled. This is a condition that exists in the real world. This could exist. So the tank has to be designed to withstand that. If we have to service this tank and empty it while it's backfilled, this could very well be the condition it's in. Now we got wastewater or water inside the tank, and of course that's going to help us because it's going to want to push outwards to counter some of that soil pushing inwards. But then you have the additional weight of the water pushing down that makes more weight pushing up, etc. So talking about buoyancy for a moment, and I believe in the rules it does actually address, making sure that the tank doesn't float or doesn't move due to high water table conditions. So concrete tanks can float. I mean, that has happened. It's harder to do because you're talking about obviously very heavy material, but it can happen. So in order to make sure that doesn't happen in a water table environment, that it's incumbent upon the designer to make sure that the tank is designed to withstand those buoyant forces if in fact buoyancy issues could arise in that area, if the water table could come up. So that's very important to do, so there's a couple of things we can do. We can either add a thicker base to the bottom to add more weight. We could extend the base out. That's been done, where the base is extended outwards so that you provide a shelf for the soil to sit on, and that really helps keep it in place. So sometimes we've got to do that, but many times the tank just by itself, just due to its specific gravity, due to the fact that it weighs 2.65 times more than water or somewhere around that, it's pretty good at staying in place. But it can happen. Now, we do have a calculator on our website, free of charge. It's there. It's an Excel-based calculator. So if you like playing with Excel-based calculators, feel free to go in there and mess around with it. There are cells that can be filled out, and there are cells that you can't mess with, the formula cells. So you can go in there and put dimensions of your tank and the other things, and then it'll tell you, all right, the tank will float or it will not with a certain amount of factor of safety, right? So that is something, I know the state of Ohio, there's some folks there that use it. So just something to double check. And you can do manholes, you can do round structures, and you can do rectangular structures. But that's for the producer to make sure that the tank will not rise in its intended conditions. All right. Now, one other thing in the TCEQ that it talks about is this ASTM again, American Society of Testing and Materials. American Society of Testing Materials has testing standards for just about everything, okay? These bottles of water right here, the plastic, they probably have an ASTM test for that. They don't just do concrete. They have test methods for everything. All right, they have a specific ASTM for septic tanks. Not only septic tanks, precast concrete septic tanks. It's ASTM C1227. I go around the country and I talk to authorities and I try to get them to require ASTM C1227. Just require it. It's there. Everything you need. You don't have to rehash everything and put everything in your rules. It's right in there, how to do a quality tank. And guess what? Texas has done it. Partially, but they've done it. One of the few states. They require, now what you can do is you can require certain parts and parcels of it, and they require the sections under materials and manufacture and structural design. So those sections out of the ASTM C1227, this is very important, the 2000 version, okay? Because we're on the 16 version. So it gets revised, but it's the 2000 version. And there's some things that are different in 2000 than now. For example, now you can use fibers, right? There's a section that says you can use type 3 fibers in septic tanks. In the 2000 version, it doesn't have anything on fibers in there. So maybe eventually in the next rule change cycle, they'll look and they might want to upgrade to a later ASTM C1227. I'm not sure, but that's the one, 2000. Okay, so if we look at the materials and manufacturing section for just a second, because I just want to clarify a few things that have to do with the tank, the inspection of the tank, and what the expectations are for it to be watertight and durable, the things we talked about. So here's ASTM C1227. This is the 12 version. But up there you would see 0, 0 for the version that is mentioned in the rules. So under the materials and manufacture, it says, under structural design, it says that design by performance requires the manufacturer to demonstrate that failure will not occur by physically applying loads to the product. The load applied shall be 1.5 times the anticipated actual load. So I have a choice. If I'm making a tank, I have a choice to test it by submitting it to an engineer and saying, calculate the loads on that and then stamp it and tell me it's fine. Okay, stamp. All right, there's my TCEQ. Here you go. This is my submitted design. I can do that. Or I can test it by performance, which means I can go out in my plant, put the tank out there, and actually test it by putting forces on. Now, how would I do that? Easiest way to do it is by vacuum. Okay? So you pull a vacuum inside the tank. So basically you're changing the atmospheric pressure inside to, and then the atmospheric pressure on the outside remains around 15. The inside, you lower it so that it simulates the highest load. You got to find out what the highest is. And then you pick the highest one, you pull 5, 6, 7, 8, 9 inches, whatever it is for structural, and you pull that vacuum. And that simulates the loads on the walls. It's nice and distributed. And sometimes what precasters will do is they'll put sandbags or additional weights on the lid to simulate that additional load on the lid, okay? But that's what they'll do. So they can either do that or do it by engineer. So that's what that means. And it's important that they take a load that's 1.5 times. So that gives you a little extra fudge factor, right? All right. Tanks shall also be designed so that they will not collapse or rupture when subjected to anticipated earth or hydrostatic pressure when the tanks are either full or empty. So that's very similar to the language in TCEQ, but I just want to mention that. That's in ASTM, okay? And that's referenced in your rules. And then this is something that talks about the loads that shall be used. And a lot of times in the rules, it'll say, when you design the tank, use this. And it'll say 250 pounds per cubic foot, or square foot rather, or something like that. I didn't notice in the rules that it had a load, but it might. I didn't. But it said, unless heavier loads are expected, the minimum live load at the surface shall be 300 pound-foot per square foot. So it's giving us the loading on the surface of the tank. That's the minimum that we have to use. Okay. So that's the ASTM. That's the expectations. You were talking about strength earlier on, and the strength of the tank is the strength of the concrete to be able to withstand some of these loads, right? Because it's going to want to push in on the walls. So that strength is very critical to that performance, and we'll talk about that here in a little bit. So critical aspects of the septic tank. So if I look at a typical septic tank, a top seam, which most tanks here are top seam, right? Are there any mid-seam tanks in Texas? There are? Okay. So, but the ones I've seen so far, at least outside, and that some producers here were top seam. But you have the risers and no risers on this one, but risers and access. You've got the horizontal joints. You've got the pipe connections, and you've got the material itself. Those are the 4 areas that something can either get in through or out through, right? So those are the 4 areas we got to worry about when it comes to making a watertight tank. Those 4 areas. So the first one, the risers and the access, and I talked about that a little bit this morning, but in order to make that a watertight system, the best first step is to have that first section cast in. That really takes care of a lot of headaches. Have that first section cast in at the plant. It comes out. It's in there. There's no worrying about water gushing in on the side in that first joint. It's in there. It's sealed. It's monolithic. It's part of the lid, right? And sometimes that's all you need, just that one riser section. But if you need to stack more risers above that, use some butyl sealant or whatever goes with that particular system, whether it's plastic or concrete, and keep that water tightness going. But that's a good first step. But, a lot of times the water tightness, it seems like we worry about it up to the risers, and then at that point we're like, oh, that can be where we get the most water is up at those risers, right? So talk to your supplier about it. If he doesn't cast them in, see if maybe they would consider doing that. It doesn't have to be. You can use butyl sealant to seal that first section down, but boy, it certainly does help. The horizontal joint. So that joint, that first joint, whether it's at the mid-seam or the top seam, and you know what? Guess what? Mid-seams are fine, okay? I know there's this thing about, oh, mid-seam. You know, the middle joint is underwater. I understand that, and that makes people nervous to have the mid-seam underwater. But at the end of the day, if that seam is sealed right, sealed properly, it'll never leak, and it's actually a stronger tank in terms of the walls when you have a mid-seam rather than a top seam. So it's not a setback or anything like that. Now, but if you get top seams, those are great. The horizontal joint, now the key is to seal that. And ASTM C1227 talks about a maximum gap between the two joint surfaces before the sealant's applied, and it's supposed to be 3/8 of an inch. Once you put the sealant, obviously that gap's going to grow a little bit because you got that sealant in there. But I don't know what kind of joints they have here. Are they flat joints? Are they keyway joints? Do you see different systems with different producers? Okay. But the key is to how we're applying that sealant. Because we don't want water getting through, obviously, in or out. But worse yet are roots. You guys ever see these roots get through? Yeah, I see a lot of nodding heads. They're the worst, right? Once those roots start getting in there, man, say goodnight. I mean, they just got to find a little water and then follow it in there. It's just amazing how resilient these plants are. Okay, so the joint sealant, now, since these are top seam, I assume that a lot of times when the tank arrives on site, you may not see the sealant get put on, you know, because the lid's usually already on it, sealant's already on it, they put it in place and you move on. But when you see the sealant being put on, or for you producers in the room that put the sealant on, make sure, a couple of things, okay? First of all, use a quality sealant. Just use a quality sealant. C990 sealant. If it conforms to that, that's what it's made for, okay? That's what it's made for. Now, when you put the sealant down, just avoid putting the sealant, joining them at the corners. Avoid joining them at the corners. If you can bring that, you know, because at some point you're going to have to join two together. And if you could knead those two pieces together, that's great. But bring that one about a foot around the corner and then knead it there. If you knead it in the corner, you bring it in the corner, you just increased the risk of a leak. That sealant, its positioning and the way it's put together, it's not complicated. But that extra care can mean the world, can mean such a difference for that homeowner and for the maintenance provider. So come around that corner. And then when it comes to the sealant, I don't know why some people do this, but they like to put it right on the outside. I'm going to put it right there so that people know it's right there, because once I put the top section on, it's going to ooze out and it's going to be like a bunch of it hanging out. Well, guess what? The effective area of that sealant, we want to try to keep that within the joint system. It doesn't do us much good for it to be oozing out of the tank, all right? A little bit of it's okay, but just, yeah, I've seen some tanks, it's like the whole thing's oozing out there. So now you've got this little bit inside the joint, right? So instead of doing that, why not move that in a little bit? See, like what I'm talking about with the oozing? Put it in there. It's supposed to be in that annular space. Now, even if you don't have this joint system, just keep it towards the center or use 2 ropes. I don't know, sometimes some people use 2, but it's supposed to be in that annular space. That's the idea, is that we want most of it in the tank. You know, if it's close to the outside, that's fine, but not completely oozing out. We want to try to use most of that area, that effective area. We want to use it in that joint system. The other thing I'll say real quick about these joints is that when the tank comes out, where you're applying that sealant, that surface, just pay attention to that surface. If you're having any issues with that surface, talk to the precaster. Hopefully there's no issues. But sometimes, depending on the way it's poured, the tank's sometimes poured upside down, sometimes it's poured right side up. But that surface there where the sealant goes on can be all flaky and be honeycombed a little bit and stuff like that. And then you put sealant on it, and the seal is fine, but the water's going to go around underneath the sealant and then go through. So it doesn't do us any good. So that should be a good hard surface, all right? If you're noticing that it's flaky and that it's poor, then that needs to be brought up. Say, hey, what's going on here? Because if they're pouring it right side up, That's what happens, is that the concrete is poured, and then the surface, they're just not finishing it right, okay? So if you run into that situation, let me know or let them know. Here's the thing about the 12 inches. Bringing it around the corner, kneading it into one piece, wow, make a big difference. Make 2018 the year of the knead, all right? For the love of Mike. All right, so you knead it together, because you might think, well, the picture on the right, oh, once those two sections come together, it'll squeeze together. It'll be fine. No, they may not. So take that extra piece, knead it. Also, don't stretch them together. Oh, not that anybody would do that, but, stretch them together, because now you're reducing the area. So, and then even the one on the left, you may say, what's wrong with that? But even that can leave a little pinhole once the two sections come together. So it's best to just knead it. Now, the thing about a vacuum test, remember I talked about vacuum testing earlier, the thing the vacuum test will do is it'll really, there's a lot of force in that vacuum test, even if you're just doing a water tightness test. And it'll suck that lid or that top section down even more, to the point where if you're using a quality sealant, you could turn around and pick up that tank by its lid. I mean, if it's a top seam, that sealant is that strong. And we were just talking about that situation out on the exhibit floor, where they were trying to take a lid off, and yeah, they couldn't get it off. I mean, they pulled, and then they had to sit there. Well, it finally came off, but you can just imagine, finally the bottom came off, and then this went like this, and the truck almost tipped over. So, but yeah, that sealant will really grab onto it. So, okay, any questions on the sealant? The horizontal joint, okay. All right. Pipe connections. Now, I'm a little confused with the TCEQ rules. Any TCEQ people here, maybe you can clear it up for me. But in the rules it says, all inlet and outlet devices shall be installed watertight to the septic tank walls, period. Now, what does that mean? What defines installed watertight to the septic tank walls? So let me ask you this. Is it acceptable to just grout a pipe into the wall? If you say, well, it's watertight. It's watertight right now. Is that acceptable, you think? Anybody got an opinion on that? Or do you have to use a connector or some kind of... Do all tanks have connectors? They're rubber connectors. Okay. All right. I hope so. I really do. Because the grouting of a pipe into a tank just doesn't work. If you're looking for a watertight connection, that's not going to work. Because it's not going to move and seal itself, right? It's not elastomeric. So using a gasket, and we have some at our booth, by the way, some gaskets, but using a gasket or a seal that is cast into the tank is the best situation. Then it makes it easier for the installer, doesn't it? I would think, as they come in, they just run their pipe in there, not too far, right? And I hear those stories about the pipe being run up against the inside baffle. But you run it in there, and then you just tighten it up, there's a clamp usually. So there's different systems. There's a clamp, and it's got to be tightened to a certain amount. You got to clean the inside of the seal, things like that, the pipe. But yeah, it makes it easy. Now, I know that there's some precasters, I don't know if anybody ever from around here, but I've seen tanks get shipped out with a stub of pipe in it. And, they do it for good intentions. I'm trying to be as helpful as I can. And it comes out with a stub of pipe. Now, I don't know if that happens here, but the only problem with that is now you've got a pipe joint right outside your tank, rather than running a full stick. So that could be an issue, can't it? Because then you get that, you can get that, where the joint is, you can get that little P-trap that forms there. So it's better, isn't it better to run a full stick right out of the pipe, right out of the tank if you can? Or at least a longer stick. So, I don't know. As much as that's a service, it can be an issue. But anyway, the main thing is, I don't know what this means. I would rather it say, and I can provide language, but I'd rather it say, use a resilient connector as per ASTM C, I can't remember. Does anybody here know? Harry, are you here? No. All right. But anyway, the ASTM for resilient connectors. And then there's plenty of them out there. We're not restricting trade. There's plenty of them that supply those kinds of gaskets. Okay. pipe to tank. So these are flexible. Then there's some that you can put in after the fact. I mean, if you're coming to a tank that has a hole, you can put one in there that tightens from the inside, and it tightens up against the outside wall. So there's different types. But it prevents exfiltration and infiltration. It's a flexible connection, okay? Provides for angular deflection of the pipe. All right. Then there's the material itself. Can water just get right through concrete? Well, it can eventually. Even a good quality concrete. Now, concrete's porous. It's a hard sponge, okay? It's got pores in it. Can't avoid it. A good quality mix could let water through after about maybe 2,000 or 3,000 years. That's a good quality mix. If you leave it in there and there's water up against it, so if you got a septic tank that's about 1,900 years old, you may want to check on it because it can get through there eventually. So good quality concrete should take that long for water to get through a 4-inch wall, okay? Now, that all depends on the porosity of the concrete. If those pores in the concrete that are already there are big enough and close enough to be able to provide a path for water to go through, oh, I'll go through this pore, and then I'll go through this pore, and then through this, then suddenly you've gone into a watertight issue, and it's going through the material. That's got to be pretty bad quality concrete. But if you got water seeping through the wall itself, it can happen, but that's bad. You know, that's a concrete that was made with way too much water, right? If you want to make a bad concrete, put a whole bunch of water in it. And then you'll get a lot of pores, and then it'll be permeable, okay? So we don't want that. So the people that make precast concrete septic tanks, they should know this, right? So they make a concrete, they use materials, they use methods to make sure that it is dense enough that it's never going to be an issue. The only way you'll get water going through the concrete is if the concrete's cracked or there's, you know, or it's been shattered in some way, okay? Now, so in that ASTM C1227, remember I said earlier, we include by reference these two sections, and one of them was structural. This one is the materials and manufacturing. And it says right in there, the cement shall conform to the requirements of C150. That's ASTM C150. And that has requirements for the cement, very, very strict requirements. Okay? In precast, we usually use a type 3, maybe a 1-2. 3 is a very fast-setting cement. 1-2 or a 1 is a normal cement. 2 is moderate sulfate resistance. But there's different cements, and we have cement samples at our booth. You can come look at it. So you can use, and it's called Portland cement, by the way. That's not a brand. That's not a brand. Portland cement, the reason we call it Portland cement is because when it hardens, it kind of looks like the stone from the Isle of Portland, which is in the English Channel. That's what Joseph Aspdin, that's why he called it Portland cement. So there's a little trivia for you. It's not a brand. It's not from Portland, Oregon or Portland, Maine. So that's why it's called Portland cement. Anyway, so it has to adhere to that ASTM. Aggregates, it's got to adhere to a really, really strict ASTM. You'd think, oh, we're just taking rocks, putting it in there. No, those rocks, they got to be non-reactive. They got to be clean. They got to be graded. I mean, you know, it's got a lot to it, okay? That's in the ASTM, so you require that, TCEQ. The water used in the mixing of the concrete shall be clean and free of injurious amount of oils, alkalis, salts. So if you're using potable water, you're pretty good. You're all right. If you're using well water, then our members have to get it tested as per an ASTM. And then strength. You mentioned PSI earlier. So the minimum compressive strength for design shall be 4,000 PSI at 28 days. Okay. So 4,000 PSI means pounds per square inch. So that means the concrete can be, now that's compressive strength. That means it can be squeezed at 4,000 PSI before it breaks. All right? So that's what that means. So that's its compressive strength. And the reason I got a turkey there is because I want to explain something about the 28 days. Because there's actually an authority, there's actually a couple somewhere that have a rule that you can't ship your tanks until 28 days. There's a little misunderstanding about the 28 days. The 28 days, there's not a magic formula that concrete at 28 days, bing, it's ready, like a turkey, like a little popper come, oh, it's smell that concrete. You know, it's not magic. 28 days strength means that 4,000 PSI is the 28-day strength. It's saying by 28 days or before, it's got to be 4,000 PSI. Most precasters will hit that in a couple days, if not the next day. So as long as you hit that strength, if you hit it in 3 days, then it's ready to go. It doesn't have to wait 28 days. That's not, 28 days was just picked because it corresponded to 4 weeks. And so if it takes 27 days to get the 4,000 PSI, then that qualifies under this rule. If it takes 29 days, then that tank has to be rejected. Because, as hydration occurs and the concrete gains strength, it takes some time, like your driveway. If you get your driveway poured, they tell you not to drive on it for what, 7 days, 10 days, whatever. Because it's got to, but they don't tell you not to drive on it for 28 days, or maybe they do, I don't know. But it's got to reach that strength, okay? So that's what that means. So if somebody's telling you not to ship tanks or you can't take a tank that's younger than 28 days, have them give me a call, because that's not what this was meant to be. All right, any questions on the strength? Okay. Oh, here's the thing on the curing. So within the same ASTM, it says precast concrete shall be cured. Cured is the situation where we're letting the hydration happen. We're letting the cement and the water mix and get, form the concrete around the aggregates. So that's curing. We provide it with enough temperature and moisture and time to be able to develop those characteristics. So it says that will develop the specified compressive strength at 28 days or less. Or less. All right? Okay. All right. Defects. I never like to show defects on precast concrete. It's so hard to find. But I was actually able to manufacture some. But I want to show you these because if you're accepting tanks on behalf of the owner and they're being unloaded, then there's certain things in an inspection or as an installer you should be looking for, right? You may not be a concrete expert, maybe you are, but if you're not, you don't know if hey, the fact that I can throw a cat through this right here, is that okay? I don't think it is. And they say, oh yeah, that's fine. Of course the truck, you might say, oh no, that's fine. Here, I got some stuff in the truck from Home Depot. I'll just patch that right up. So that's where you got to ask the question, oh, hold on a second. I don't know about this. So cracking, bug holes, honeycombing, cold joints, exposed reinforcing. Let's look at that real quick. First of all, if you see cracks, and we're not looking at the crack on the ground there, we're looking at up here. If you see cracks that are perfectly lined up with reinforcing, in other words, they're very straight, cracks tend to not be very straight, okay? But if they're straight and they're lined up with reinforcing, then that's a structural issue, and there's not much you can do to fix that. That should be rejected, okay? So cracks that are lined up with reinforcing like that means that either the reinforcing is not deep enough, or there's something that's gone wrong there, okay? So that's an issue. Now, other cracking, sometimes you might get a little surface cracking. You got to go right up against it and look oh, I see it, a little cracking right there. All right, that's called drying shrinkage cracking or shrinkage cracking, plastic shrinkage cracking. It's early age cracking that can occur sometimes when the bleed water at the surface of the concrete dries up really quick and the surface kind of squeezes, it compresses a bit, so there's some surface cracks that can occur. These cracks are so minute in depth, they're very, very shallow, and they're not going to pose an issue to durability of the concrete. If you got to go right up and look at it like this, if you see that sometimes, that may not be an issue, okay? That's a drying shrinkage crack. But a crack, like one crack that goes down the side, if you got one isolated crack, a lot of times that's a structural crack, because cracking due to plastic shrinkage happens. It's like a little series of map cracks. Exposed reinforcing, and here you see there's some reinforcing right there, okay? Or there on the corner, kind of hard to see, but there's some right in there. So exposed reinforcing, that's bad news, any exposed reinforcing, because that corrosion is going to happen right away. And that corrosion will take place, and then when steel corrodes, it expands, right? It forms like an iron, and it expands, and then it'll start spalling. Not fair to the homeowner, right? Cracking, that's an example of a crack right there. That's not acceptable. Honeycombing, if you get pockets of, that's pretty extreme right there, but pockets of aggregate, but there's no paste, like the paste has been washed away somehow, that's an issue. That obviously, that's not acceptable. sometimes you get some on the corner like this, okay, a little bit on the corner because maybe the form leaked or. So some minor honeycombing like that one there, he's cleaned up and he's getting ready to patch it with a cementitious material. Yeah, that's okay. You're patching it with a cementitious material. There's no exposed reinforcing. You know, some on the corners like that, not a big deal. Okay, but that's in moderation. So if you have questions, if you doubt it, you ask the question. Hey, what's going on with this? Can you tell me about this? Cold joints. So this is a foundation wall. I couldn't find a cold joint in a septic tank. But this is a foundation wall. And what's happened here is when they poured this foundation, they poured this, and then maybe they broke for lunch, or the truck was running late, or whatever happened. And then they came and poured this layer, okay? So that's bad news right there, because now you have a joint here that is compromised, that is probably going to leak water or have something happen to it, okay? So a cold joint in a septic tank, where you would see that is if in the event, and I don't think anybody does this, but in the event that somebody is pouring tanks out of ready mix that's left over at the end of the day and say, hey, when you have leftover concrete, come over to my plant, dump it in that form over there. And then after a couple of weeks, I'll have a tank and I'll sell it, right? So you'll see all these lines in there from cold joints. You don't want that. That is bad news. There's no repairing that. So hopefully you never see that, but. There's another one. And bug holes. Now, bug holes is something that concrete will have to a certain extent. You know, it might have little holes in it. These little air bubbles. You ever see that? Okay. Now, some of the tanks I've seen out there, outside, there's tanks outside, by the way, concrete tanks. I'm excited about that. They look great. I mean, I don't know. I'm not even sure who manufactured some of them, but they all look fantastic. And now, there's some bug holes. But that's okay. It's going to have some bug holes, okay? That's part of it, and that's not a durability issue. If it's, you know, because usually it's like maybe part of your fingernail can go in there. But to a certain extent, if it gets to a point where you can stick your old thumbnail in there or there's a lot in one area, then you can ask the question, hey, what's going on here? You have a question back there? Oh, you're just stretching. Oh, you're just stretching, okay. So those are bug holes. And what that is basically, there's air in concrete. You know, when you pour it, you trap air in there, and the air is trapped. And then when you start consolidating it, then the air like tries to get out, and it goes to the form surface, and then it tries to go up and out. And maybe it doesn't make it all the way out. And so it comes out like that. Okay? So only in excess is that an issue, or deep. So this is what we want. We want tanks with sharp corners. We want them to look good, right? We want a good-looking tank and smooth. So, and that's, you know, the technology and the materials are there to do that. All right. On installation. So installation best practices can avoid costly issues in the future, that's for sure. When it comes to the bedding, making sure the tank is level, making sure the inlet and the outlet elevation are in the right place. You ever put a tank in backwards? Which it might be hard to do here in Texas because they require you to say in, out, or whatever. They require you to put the out on the out, which is great. So, but sometimes, you know, they put the tank in backwards. It's like, oh, well, we'll just shimmy up this side. There, now we're fine. So the level, the bedding, the proper application sealant when we talked about, and then care when backfilling. See, the thing about precast concrete tank, precast concrete is pretty robust, right? It's pretty robust, so sometimes you tend to like, it's a concrete tank, it'll hold up to anything. So you do have to be careful. I mean, yes, it is robust, and it'll take a lot of punishment, but there's still some best practices we recommend when you're backfilling and doing those. Now, TCEQ requires, it says, a minimum of 4 inches of sand, sandy loam, clay loam, or pea gravel, free of rock, 1/2 inch in diameter. I'll tell you, that's a pretty strict one. 1/2 inch. Shall be placed under and around all the tanks except poured-in-place concrete tanks. You guys all do that, right? All right. So, unless otherwise approved by the permitting authority, tank excavations shall be left open until they've been inspected. Tank excavations must be backfilled with soil or pea gravel that is free of rocks. Once again, larger than 1/2 inch in diameter. I've seen rules that say 3 inches in diameter, or 2 inches, or maybe an inch. Class 4 soils and gravel larger than 1/2 inch. So once again, what they're trying to do, and this is an all-encompassing installation, you know, for every kind of material. But what they're trying to avoid is those point loads that when you get large rocks or the homeowner comes out and goes, hey, while that hole's open, I got this old washer. Can I just throw that in there? Or I've got this old mother-in-law. Can I throw that in there? You know, whatever. That point load, that mother-in-law point load, could cause some issues. So we're trying to avoid that. So trying to have a level base, and then if that guy from WOSA is in here, that's probably not the right slope. But this is just for illustration purposes. But you have your sub base. Now this is out of our best practices manual. 4 inches to sub base, aggregate no larger, and we say 1.5 inch. Okay, and then backfill with layer. Now it didn't say about the layer, like how tall each layer needs to be. I just noticed that. But we usually call out 24 inches, 24-inch layers of backfill. Compact it, then the next 24, compact it. So here's the tank. The markings, it does require that the markings, that it has markings that say the name of the manufacturer, where it's from, the location. It marks the inlet or the outlet. And then it also, this one says ASTM. This one says conforms to ASTM C1227. And it has the size. So it has to say the size. Which, by the way, the size, when you're inspecting it, if you're inspecting it and you're going, is this the right size? When it says 1,500 gallons, where does that 1,500 gallons start? At the flow line, right. Okay, makes sense, right? It's not the capacity of the tank. The tank itself has a higher capacity than what it says there. The tank itself, the total volume, but flow line, exactly. Outlet flow line. So real quick, I'm going to test you guys. I'm going to quiz you guys on the TCEQ. So real quick, what's the minimum liquid depth of a septic tank according to TCEQ? 3 foot. Do I hear something else? 30 inches. Who said that? Who said that? Ah, all right. You can come to our booth and get candy. Everybody else can get candy too, but you can come and get candy. 30 inches. That's right. 30-inch minimum. All right. The minimum fall between the inlet and the outlet. What is it? 3? Yep, at least 3 inches. Very good. Very good. And then when you have a 2-compartment tank, the first compartment has to be how much of the volume of the total tank? 2/3. It actually says half to 2/3. But yeah, usually it's 2/3, right? And that's as far as it goes. I mean, it really doesn't go into, a lot of rules go into the airspace. It goes into it does say also the transfer port. Doesn't say it does say minimum 3-inch, but the transfer port needs to be at 25 to 50% of the water depth. Okay? Did you have a question? Yeah, most of the stuff you talked about, it seems to be about conventional tanks, correct? Yes. I've seen several problems on the aerobic system where they're 4 chambers. Okay.
A lot of that don't apply to it, but at the same time, where you have that mid-seam,
Yeah.
I've had it where the mid-seam goes bad and the aeration tank is mixing with the trash tank.
So, okay. Okay, so you're talking about a mid-seam tank that has 4 compartments. So basically clarification, aerobic, trash, aerobic, clarification, and whatever the 4th one is. What is it? Pump, yes, I'm sorry. Okay, so he's talking about a mid-seam tank that has 4 compartments, and so yeah, you got to join those walls, all those compartment walls. And so what's the problem with the compartment walls? They're just not lining up, or they're...
The butyl.
Oh, the butyl doesn't stop the...
When we pumped it, all the aerobic water was flowing back into the
Oh, he's saying the aerobic water was mixing into the trash tank. So the compartments weren't sealed off from each other. Anybody else run into that? Okay.
where there's a hole between the clarifier tank and the pump tank. And
Okay.
it was on a drip system, so it's filters on this system.
Okay.
And they kept getting plugged like every other day.
Oh, really?
And so we eventually pumped it, got in the tank, found there's a hole between the 2 tanks.
Oh, I see. Well, I'd like to talk to you about that a little more afterwards, if you don't mind, just for a second. Yeah. Because I want to explore that a little bit. But yeah, you're right. This doesn't apply to tanks that are specially designed for proprietary systems, but it should still seal between systems. I mean, that's... And the thing I'll mention about that port real quick is you know, not as much, in a grease interceptor it's even more important. But in a septic tank, part of the reason, part of the efficiency of its separation is retention time, right? We don't want the stuff going all right through right away, right? So the retention time is important. If you have a small hole in that compartment wall, it's just going to suck the stuff from the first chamber right into the second chamber, because that Venturi effect, you know, that it has. So the larger that hole, or if you have sometimes people have a T in there, but that helps a little bit with not short-circuiting, adding some retention time, you know, so that's a design thing that's really important when it comes to grease interceptors. In grease interceptors, a lot of our members will put slots in there just to make it so it goes across nice and smooth. But, okay. Septic tanks, now the testing, if you're witnessing testing on site, do you witness testing on site sometimes? No? Water testing? What's that? You fill it up. Yeah. Okay, do you ever do vacuum testing here for water tightness? Okay. So there's two ways. You can either do negative pressure vacuum testing or water method hydrostatic. So the thing about the water test versus the vacuum test, when you're talking about a true water tightness test and actually even structural test, the vacuum test is actually more efficient than the water tightness, and I'll show you in a minute. If you do water pressure testing, which is fine, which basically under ASTM, you fill it up, right? And then you wait 24 hours, and you come back, you fill it up again, because the water might have come down just a bit, because it gets soaked up right into the surface of the walls. And then you watch it for an hour, and it's got to hold. That's the water tightness tank, right? Now, the thing about the water tightness test, if you can imagine, in the tank, you know, at the bottom is going to be your largest load and the most pressure, right down there at the bottom, where there's no joint, there's nothing going on down there. And then as you go up, as you get to the surface, then you have, you know, that force goes down, right? So you get all the way to the surface. If you do a vacuum test, it's constant throughout. But the hydrostatic test is acceptable, it's fine, it's in the ASTM C1227. But a vacuum test is also, you know, if the TCEQ doesn't require it, that's fine. But it's also something I like to promote. Now, the vacuum test shouldn't be done after backfill. That's just the only thing. If you do it after backfill, now you're endangering the people that are doing it, because now you got the added pressure of water in the soil and everything else. It's supposed to be done without backfill. But the water test is fine. Now, the thing about the water test is how high you go with that water. Now, I know this is, you know, if you've got 5 feet of riser and you fill it up all the way to the top of the riser, that's a lot of pressure on that lid. And that can be an issue. I don't think that's the intent of, you know, when you're testing the joints, that first joint, what you're more concerned with is that first horizontal joint, at the lid. You don't want that to leak, so that's fine. Bring it up above that. But to go up 5 foot, you know, I don't know what the requirement is exactly. I don't have it, but I know it's something about going 2 inches above a joint or something. But if you just go up into the lid just a little bit, that should suffice. Especially if that first riser section's embedded, that's not going to leak, right? So the joint you're worried about the most is the joint at the lid. But I don't know if you guys have ever run into that where the lid might, you know, that's a lot of upward buoyancy force pushing up on the. Okay, but vacuum testing, that's just different. There's different vacuum testings for different products. One for septic tanks, one for grease interceptors, and then there's even a third one for just precast concrete tanks. It's actually a test for on-site, where you test it in the hole, but not backfilled, just it's in the hole. You pull 4 inches for 5 minutes, and it can't leak at all. Now, the old 1227-00 or 05, it could actually leak 90% of the 4 inches, but so it could go down to 3.8 inches, but not anymore. Now it's no drop. For grease interceptors, it allows half-inch drop for whatever reason. Okay? So, we're talking about quality tanks. We're talking about tanks that are watertight. We talked about water tightness. We talked about strength, the 4,000 PSI or above, 5,000, 550, 500. If we're aiming for 4,000, if the minimum is 4,000, then chances are they're not aiming for 4,000. You know, they're aiming for higher. And the way they test it, if you've ever seen a compression test, they put a cylinder in a machine, they test it, they squeeze it until failure, and that gives you the strength of the concrete. But all of these are part of a quality control system at the plant to be able to deliver this. Strength, durability. And durability, the number one thing for a durable tank is density. The tank not letting water in. Because anything that destroys the concrete is going to be traveling in with water. You know, so it's having a dense concrete with a low water to cement ratio and good quality materials and good manufacturing practices. And we have all that information available. So our members, we teach, we educate, we train on this all the time. The contractor, what responsibility does he or she bear is obviously the backfill, the sub-base, all that stuff, making sure it's put in right. The inspector, you know, the person inspecting the tank, knowing what to look for, okay? And if they have questions, if they see something I didn't cover here, or if they, you know, it's to be able to stop and ask the question, right? And then finally, the homeowner, well, the homeowner responsibility is to maintain the tank, right? So the more you maintain the tank, the more that the system's going to operate for many, many years to come. So making sure, so ask your precaster, if you got a precaster that supplies your tanks for, ask them about their quality control system. I said, what kind of quality control program you use, by the way? Some of our members are certified, which means that we have a third-party engineering firm that comes in unannounced. Hello, welcome. They come in, they inspect your plant to make sure you're doing everything you're supposed to do quality-wise. And then as long as you're doing what you're doing, you get to keep your certification. So we have some members here in the area that do that. And they're required to follow all of C1227, not just the parts that TCEQ has. So we expect water tightness, strength, durability, and compliance with the rules that you guys know very well. The water tightness, the key is low water cement ratio. If you're going out this weekend to pour some fence posts or your driveway or anything, don't throw a lot of water in it. That's the enemy. So low water cement ratio, strong, dense. Allow it to cure. It doesn't take 28 days, but allow it to cure under optimum conditions. Proper joints and connections with the right use of sealants. The year of kneading and the connections. Understanding the anticipated load. So we talked about the anticipated loads on the tank. And the producer should have a quality control program. Thorough field inspection from the inspector, the authority, and the installer to ask the question. Use installation best practices, which, by the way, we have in our best practices manual. Use us as a resource. Come see us at our booth. We have candy. We have other stuff. We have best practice manuals. We have homeowner manuals. Come see us. Come say hello. And we're here for you. We're so glad that we had the opportunity to be here. We'll be here till tomorrow, too. Can't get enough of it. There's our website, precast.org. Best practices manual. There's my name and number. Sorry, that was quick. But I have business cards. Any of you want my business card? I have at least 20. And are there any questions? 2:15 for that. Yes, sir. Does anybody here know what a slump test is? Oh, there's a couple. Yeah, the guy over there. So a slump test is where you put concrete in a cone, right? You put it in a cone. There's a whole procedure to it. And then you fill it up, and then you pull the cone, and then you put it, and then your concrete's going to go, blah. It's going to settle a little bit. You put the cone next to it, and then you measure how much it's settled. That's the slump test. Well, it depends. Now, it's just a measure of workability. So really what we're doing is we're measuring it to see if it's 3 inches. Okay, so it's 3 inches. The next one we do, is it 1 inch? Is it 5 inches? If we're all over the place, there's something wrong. And one of the reasons it could be all over the place is, for example, our aggregate. If our aggregate is stored outside, which 95% of the time it is, and it's been raining, that aggregate, we just throw it in the concrete, all that water on that aggregate has just raised our water cement ratio. So our slump will go up because it's wetter. So things like that. So it's more of a measure of consistency, workability. It doesn't correlate to strength or anything like that. And as a matter of fact, there's a concrete that a lot of members use, including probably the concrete you see outside there, which is called SCC, self-consolidating concrete. You don't even have to vibrate it. And that, you can't do a slump test. You have to do a spread test. Because when you pull that cone out, it's like pancake batter. It goes like this. So you have to measure how far that ring went. And the key is You might think, like, how do you pour concrete that wet? Well, it's wet. It's wet in the sense that it spreads out through the forms, but the aggregate gets taken out with it. The aggregate stays in suspension. That's the whole magic behind it. And so when it pours through the form, it takes the aggregate with it. And it's a whole thing with admixtures. I could talk another hour about SCC. Oh, I love it. So anyway, but that would be a spread test. All right. Thanks for your question. Anybody else? All right. Thank you.